Hi everyone, I'm Samya Sharmit and today I'm going to talk about the K-nearest neighbor algorithm, which is one of the simplest and one of the most used algorithms for solving classification problem. So the concept of KNN is that if you're like your neighbors, then you're one of them too. For example, if an apple looks more similar to an orange or a melon than a rose or a lily, then most likely an apple is a fruit and not a flower. So to have a better understanding of the KNN algorithm, we'll now have a look at an example of Game of Thrones. So suppose we have a data set where we have been given the data of the characteristics of different characters from different houses of Game of Thrones, like their hair color, color of their eyes, and we also know the houses they belong to. But let's just assume that we don't know which house Jon Snow belongs to. So we'll now have to predict the house Jon Snow belongs to using KNN algorithm. So how is KNN going to do that? KNN will first calculate the Euclidean distance of each character's features from Jon Snow's features uh, and then sort them in ascending order. So after that we will choose the closest neighbors of Jon Snow's character, so who have the similar features that Jon Snow has. As you can see that I have chosen three characters here because the value of k is 3. K is a positive integer, which is the number of neighbors that we are going to select for determining the class value of the test data. So as we have 3 as k here, that's why we are selecting 3 characters. But if we had 5 as k, then we would have chosen 5 characters here. So now that we are done identifying the closest k number of neighbors, we will now check the class values of these neighbors. So as we can see that two of the characters are Targaryen and one of them is a Stark. So as the majority is Targaryen, so according to KNN algorithm, Jon Snow is a Targaryen too. So as we have seen that KNN is a very simple algorithm which determines the class value of a test data based on the class value of the majority of the neighbors they have. So we will now have a look at the code. So the first thing that I've done here is I have imported the libraries and the data sets. After that I have stored the data set in iris, and then I have copied the features which are iris.data in x, and the iris.target means the class value, and I have stored that in y. After that I have used xtrain uh, and xtest, which means I have split the features here and the outputs also. Train data and test data are the splits that I've done because I want to observe 75% of the data, which I'm calling xtrain, which means I know the features and the class values of these 75% data, but I don't know the class value of the rest of the 25% of the data, but I only know the features of those 25% data. That's why the test size here is 0.25. So I will now predict the class value of these 25% test data based on the observation I make on the train data. Here I have printed the value of xtrain.shape and xtest.shape. Xtrain.shape 0 means the number of rows xtrain has, which means the size of xtrain. So here it is 112, and I have printed few values also. After that I have stored xtrain.shape 0 in train size, which means the size of train data in train size and the size of test data in test size. After that I have created an array called pred, where the size is text size because I'm going to store the predictions that I make on test data, and that's why I have initialized all the values as 0 because I haven't done any prediction yet. After that, I have created an array called test observation where I have copied the features of the test data, and then I have created another array for calculating the distance from all other train data to test data so that I can find the closest neighbors. After that, I have copied the features of train data in train observation. So these are the train data and these are the test data. These are the features. So after that, I have subtracted test observation from train observation. Here I am actually calculating the Euclidean distance. So train observation is the x1 and test observation is the x2, so x1 minus x2 square. So after I'm done with calculating the Euclidean distances, I have initialized the value of k. So then I have created an array called s where I am storing the index numbers of the closest k number of neighbors. As k is 3, so 3 values are going to be stored here. Here I have used np.argsort. np.argsort returns the index number instead of the values. So here I have the index numbers of the 3 closest neighbors. After that, I have created 3 variables where I am uh, checking whether the value of that index is 1 or 0 or 2, which means the class value. So I'm just checking which class value these 3 neighbors have. After that, I have checked here which has the largest value, which means as I had chosen uh, as I had chosen R for 0 class value, U for class value 1 and V for class value 2. So whichever class value has the largest number of occurrences, I am storing the result in prediction. So that is the result of my test data. So this is how I'm storing the data in the prediction array. So after that, I'm done with storing the predictions, and then I have just printed the predictions. After that, I have also checked the accuracy. Here I'm checking whether my prediction and the actual value are the same or not. Then I have divided that count by 38 because the test size was 38 that I had printed earlier, and then multiplied it by 100, so I got the accuracy 39.47. So this is the KNN algorithm and the code. I hope it helps. Thank you.